leading on upstream thinking and biodiversity management for South West Water, and this will be about managing the lowland and upland farmed landscapes of the Southwest. Then we have Sue Pritchard, Director from the Food, Farming and Countryside Commission, who's going to be talking about agroecological farming, the framework and environmental land management schemes implementation in Devon. Then we've got Paul Cottington from the National Farmers Union. Paul will be talking about nutrient management and emissions trading. And then we have, last but not least, Rob Lamball from the Catchment Sensitive Farming Officer from Natural England, who's going to be talking about catchment sensitive farming. Sorry, that is the schedule for today. And without further ado, I'm going to pass over to Donna Carlos, who is going to talk about online catchment management systems.
This morning, we're going to talk to you about our ArcGIS online catchment interventions recording and reporting tool, a resource for the South West Water Catchment Management Programme that we have developed through the Sweep Whole Catchment project. This has been done in partnership with the Upstream Thinking delivery partner organisations. So I'll start with a little background. South West Water's Upstream Thinking Programme is a catchment management scheme developed to promote natural landscape scale solutions to tackle water quality issues and improve water quality at source. There have been 2 previous rounds of Upstream Thinking since its launch in 2010, with the Upstream Thinking 3 beginning in April of this year. A key feature of the scheme is the farm advisors, who engage with landowners and farmers and offer targeted advice and capital investment proposals to tackle water quality improvements, which are then 50% funded by South West Water. During phase 1 of the Sweep programme, we had the opportunity to gain an understanding of the work that was done by the delivery organisations and to support South West Water with their planning for the next round of the programme. One of the things that we identified was that the scheme would benefit from a more standardised method of recording of the activities and interventions that are completed. There is a huge volume of work done by multiple partners across many different catchments, and capturing this great work is really important. We want to be able to show what has happened, where and when, and this includes everything from the physical interventions, such as improvements to slurry stores or fencing to exclude cattle from rivers, to advice on fertiliser application rates or soil analysis. So we developed this project to build a tool that would capture this information in a streamlined and efficient way, and that would support the reporting requirements of both the partners and South West Water. Our aim was to create a tool that would provide a consistent method for data collection of all the on-farm measures and advice delivered, that would provide spatial recording to help visualise activities and to avoid double counting in reporting. We also aim to provide detailed data to help measure success and report against targets. Finally, we hope to support delivery partners working together, particularly where jointly responsible for shared catchments, identifying priorities and opportunities, and to target resources. We also hope that using a consistent recording method that means that data will be comparable for future monitoring and evaluation. I'll now pass on to Mandy, who will show you what we developed.
Hi, I'm Mandy Robinson, and as Donna just said, I'm going to show you the tool that we've created. But first, a little more information. So we developed our tool in ArcGIS Online, and this is a cloud-based solution for mapping and analyzing location-based data. Key elements of our tool are that it stores geospatial data, has a series of embedded maps and apps, and a simple user interface for exploring, inputting, and extracting data. We chose ArcGIS Online for a number of reasons, including that both us and some of the delivery partners were already familiar with ArcGIS and had the necessary licenses. We also had a lot of support from West Country Rivers Trust in the earlier stages of development, as they have experience of creating this sort of tool in ArcGIS Online. Tool development was user-focused, and we consulted and collaborated with South West Water and the delivery partners throughout the process. South West Water will primarily be using the tool to extract data for internal and external reporting, so for example, reporting on upstream thinking biodiversity targets. The upstream thinking delivery partners will be both inputting data into the tool and extracting data for their own purposes. Outputs from the tool will also be used for research in collaboration with the project partners. Another aspect of the tool that is important is that each of the partners have their own version of the tool, which they have to log into to access, so they only have access to their own data. South West Water have a master version of the tool that has access to data from all of the partners. The tool itself is not publicly available, but outputs from the tool will be used in publicly available upstream thinking reports. So this is the upstream thinking reporting tool that we have created, and it is a tab-based web application. So the first 4 tabs are for getting data into the tool, and the remaining tabs are for getting data out of the tool. The version that I'm showing you is the master or Southwest Water version of the tool, which contains data for all of the partners. So I'm going to start with the Land Unit Engagement tab. And the role of this tab is to allow users to view and input information about land units that are engaged in upstream thinking 3 into the system. So we use the term land units because there's a variety of land types that might be engaged in upstream thinking. Often it's a farm, but in some cases it could be community land or South West Water land, for example. So the purpose of this tab is for users to tell us which land units they have engaged in upstream thinking and the level of engagement. So the first step in using the tool is for a delivery partner to tell us which fields make up a farm or land unit. On this, they can enter information about this land unit using a Survey 123 form. So the data collected in this form feeds into the layer which is stored, or GIS layer, which is stored in ArcGIS Online. So some of the advantages of using a Survey 123 form are that we can restrict the answers that are given. So for example, we can provide drop-down answers, or we can also have single choice or multiple choice questions. So this improves the quality of the data because there's a restricted choice of answers. So there'll be consistency across partners in the answers that we get. And also we can filter questions based on previous questions. So it improves the how easy it is for the partners to fill in the form. So in this form, we collect data about the level of engagement in upstream thinking. So for example, the number of visits to a farmer or land manager, and whether they've been given a verbal advice or a farm plan as part of upstream thinking, and also whether there's any land under active management in this land unit. So when we talk about active management for upstream thinking, this means land that has had a change in management practices as a result of taking part in upstream thinking, or there have been physical interventions on the land. So some of the other information that we collect through this survey are information about land ownership, land type, so for example, whether it's community land, common land, or a farm. And also, if it is a farm, then information about the farm business, such as whether it's organic, whether it keeps livestock, area of different habitat types, livestock numbers, and cropping areas. So this is all useful information so that we know what sorts of land units are being engaged in upstream thinking. I'm now going to move on to the interventions tab. So this is where partners actually will digitize interventions so that we know where interventions have physically occurred as part of upstream thinking. We've categorized interventions into 5 different types, depending on how the data needs to be stored in ArcGIS. So, for example, we have point interventions. So these are discrete interventions whose location is represented by a point, and the area or length of the intervention doesn't need to be captured for the purpose of upstream thinking. So point interventions include things such as gateway relocation from high-risk areas, in-stream NFM measures, and resurfacing of gateways. We also have a line interventions or linear interventions category. So this is for interventions that we need to know the length of. So for example, ditch management, establishment of in-field grass buffer strips, hedgerow management, and stone wall restoration. We have a category of polygon interventions. So these are those that we need to capture the area for, such as creation of wet or water holding features, management of moorland, and new roofing, for example, for slurry and silage stores. We also have something we've called the land unit point, and this is for capturing advice that has been given to farmers. So I'm just going to show you an example of entering this sort of intervention into the system. So partners will need to zoom into their area of interest and digitize or put a point in the correct location. It's important that each time they have to tell us the partner that is undertaking the intervention, as this is something that's key for us to keep track of. Once the point has been entered into the system, then they can bring up a survey 123 form to tell us about a variety of advice that might have been given to a farmer or other land manager. And this is a multiple choice survey, so they can just click on as many pieces of advice that have been given. So for example, adopt phase feeding in livestock, or adopt batch storage of slurry, compost, solid manure. So this is just a variety of different types of advice that might be given as part of upstream thinking. There's also an other box in case there's additional advice that we haven't already got listed above. We also have a field parcel intervention category for interventions that take place across whole fields. So for example, arable reversion to grassland with low fertilizer inputs, or soil aeration, for example. So the whole purpose of this tab is for them to tell us what interventions have happened where, and also when these interventions occurred. So they enter the intervention into the system, they give us information about that intervention, and then they can also view the information that they've entered or download the GIS layer. So moving on to the field activation tab. And this is quite a simple tab, and the whole purpose of this one is to allow the delivery partners to tell us which land is under active management, so which fields are in active management for upstream thinking. And this is a key metric for upstream thinking, is the amount of land under active management. So partners can zoom into an area and they can either turn individual fields active, or they can turn whole land units active at once. And this just shows an example of where this streamlines the process compared to if the partners were just using desktop versions, because it's all inbuilt into the tool. So they have the opportunity to just click on a tab and then input which land is active, rather than having to load desktop GIS and then undertake a series of processes and then send the data across. It's all done in a relatively streamlined process. So moving on to the catchment scale engagements tab. So this is just for capturing information at a catchment scale. So these outlines are the catchments that are taking part in upstream thinking. So partners will just need to click on a catchment, and then they can tell us information about engagements such as total number of farms contacted or visited in that catchment, or the number of pesticide amnesties that have taken place, and the amount of pesticides collected in those amnesties. So that's it for the first 4 tabs of the tool. And the remaining tabs, as I said before, are for getting data out of the tool. So the engagement maps tab is just for partners to be able to export maps from the tool. And then I'm going to pass you over to Ben to talk about the other tabs.
Thank you for that, Mandy. So here we have a dashboard, and in each of these boxes here, we have statistics, some of the statistics used for upstream thinking reporting. Now, this is particularly useful in that it's possible to filter data sets with conditional statements, such as for the total area engaged here. In the land units layer, we're able to filter by all land units which are engaged, and then we're able to get the total area. We're also able to filter by catchment here, and by selecting one of these or multiple, you can select one or more catchments and it will filter the results. And you can also pan around the map, and as you can see, by doing so, we have changed the figure here. You may also notice that these figures are blank or 0 for now, and this is simply because the tool has not been released yet, and therefore there is no data at the moment. But when there is data inputted into the tool, then we'll find that these variables will update as each different piece of data is added. So we also have to consider that once we have all of the data, it ultimately needs to be in a form. It needs to be downloaded in a format that allows the partners to report to Southwest Water. Now, this can be quite a time-consuming activity because some of the elements need to be taken from multiple GIS layers, and some of which are in different formats. And there is filtering that needs to be required, and then calculations and all sorts. So this is why in the tool itself, this actual process is very easy, because it is all calculated automatically using this script. This script is written in Python. So ultimately, it takes all of the GIS layers and then converts them into tables. And then it filters the tables according to specific requirements and applies conditional statements, and finally merges all of the different pieces of data that are extracted and converts that into a spreadsheet, which is available to download onto the user's computer. This is very efficient, and all of that is no requirement to have any knowledge of Python is required. All that is required is just to click run, run through the script, and then produce a link. It's very simple and very convenient to use. Finally, there's also the feature to download all the GIS layers on the link in the far right here, and basically all of the GIS layers that have been produced can be downloaded to the user's computer in case they want to use it within their own GIS software on their desktop PC. That's entirely possible. Some of the users has requested this because I think it would be useful. So that concludes the tool. And I can finally go to a summary of our work. Our tool is more efficient and produces consistent data for different users, and it is also able to support further catchment management and scientific applications. We plan on releasing the tool in early November for all of the upstream thinking partners to use. And that concludes our presentation. Thank you very much for listening, and please, if you have any questions, please ask. Thank you again.
Thank you, Donna, Ben, and Mandy. That was a really nice presentation. Yeah, so now really we'd like to open for questions and participants. Yeah, really just want to give you an opportunity then to ask some of those questions. So I'm just looking down the list. I can see there has been some chat. We've got a question here from Anthony Firth. Anthony, are you able to put yourself on camera and unmic yourself and ask the question?
Yeah, sorry about that. Yeah, sorry, I wasn't expecting to ask questions, so quickly plugging in microphones and things. So, yeah, so my question was whether the tool, which looks really interesting, whether is being used in advance of interventions. Is it used in bringing information together to inform interventions? Really, is it being used in advance, basically, as a planning tool as well as a reporting tool, or is that kind of capability anticipated? Thanks.
Oh, yeah, that's a good question. Thank you. So in its current form, no, the tool can't be used for planning interventions, but we are planning to develop the tool further in collaboration with the partners. So that is something we might look to do. So we're thinking about perhaps including some additional layers in the tool. So perhaps something like pollution risk mapping, so that they can see where might be a good place to try and target interventions, but it's something that we haven't looked into in a great detail so far.
That's great. Thank you.
Thank you.
Thanks, Anthony. Anne Skinner, would you be able to also put yourself on screen and on mic and ask your question?
Hi, yeah, pardon me. I just wanted to know, really, it's a fantastically useful tool, but can this information be shared more widely with, for example, the CABA groups? And can the tool be used anywhere or everywhere? Because obviously there's a lot of people who are very concerned about the need for catchment interventions, for natural flood management, alleviation of diffuse pollution and so on. So yeah, whether it can be made available for use everywhere.
I guess the tool as we've developed it at the moment isn't going to be public, because its initial main aim is for the recording and reporting for upstream thinking. So the individual partners have their own sort of essentially private version, so they can record and evaluate their own work. So that's not publicly available. Obviously the methodology and the principle of AGOL is publicly available and could be created for anyone, anywhere. Obviously we work closely with the delivery partners, so we're familiar with the CABA packages and things like that. We're also, through our other projects and associations, we've got plans to talk with the EA about some of their natural flood management planning and recording. We also work with the university on other monitoring and evaluation of upstream thinking. So there's lots of probably opportunities in the future for us to have outputs from this tool shared in sort of more generically area, so anonymized area type data to be exported into other decision-making tools, and us, as Mandy explained before, to add other layers into our tool so that we can start sort of looking at the bigger picture. But initially the aim was to get a sort of consistent standardized recording and reporting tool for upstream thinking. So that's as far as we've taken it for now, but we're sort of at the end of the year and in the new year be looking to sort of talk to others and collaborate and see where we can take it. If that answers the question.
Great, thank you. There's one more question. Chance for Andy Bell to ask a question. Maybe this one's for you, Ben, I'm not sure. Andy, could you please put yourself on mic and on screen and ask the question?
Right, gotcha. It was really, I think it has partly been answered already, in that you got so much data and information coming in from the people using the tool, that are you able to then calculate the impact, say, in reduction of PRN from the actions that you're doing there with the program, so you can see, you can track effectiveness and what should be happening in the catchment. But I think you answered that already. So then you would have to shift out to other decision support tools, etc.
Yeah, possibly, Andy. At least what we're aiming for with this is to know locations where things are happening, at least that will sort of help facilitate. And Ben's been doing some modelling through other projects. So Ben can probably talk more about the modelling, but yeah, at least what we're aiming for is to know where and when things have happened that might help facilitate that sort of modelling in the future.
Thank you.
Brilliant, thank you very much. Well, thank you, team, for that very interesting talk, and obviously really good to be able to see some of those data coming in and the tool being used. So yeah, without further ado, I'd like to just ask you to disappear and then we can move to the next presentation. So the next presentation is given by James and also Jonathan Hubbard. And yeah, it's all about integrating landscape scale surface water management. So yeah, I'll disappear and hand over to James and Jonathan.
Thanks very much for the introduction, Ross. So just before we get going, I guess I'll just talk about the format for the next hour or so. I'm James Webber. I'm from the University of Exeter. I'm also going to be presenting with Jonathan Hubbard, who works at Pearl Frischman. We're going to spend sort of the first half an hour or so going through some of the challenges and some of the methodologies we've developed to help integrate landscape scale surface water management in the Southwest. Then Jonathan is going to go through some case studies for how his organisation, how Pearl Frischman have applied some of this technology. And then we have an opportunity for some questions and answers after that. Oh yeah, so I need to give a thumbs up every time the slide changes. So in terms of the structure for this part of the presentation, we're going to start off just by talking about surface water management, talking about SUDS and some of the challenges we face. And then we're going to present a few different tools which we've developed which can help alleviate some of these challenges. So the first is screening regional surface water flood dynamics using synthetic stream networks. The second is use of rapid scenario screening to rapidly evaluate SUDS options in catchments. And then we'll look at some application of these tools and how we can really try and take SUDS application from a sort of urban site scale through to regional scale surface water management. Just before I move on as well, I'd just like to thank all the different partners who've been involved in the Sustainable Drainage Project. So there's a group of the partners just on the slide there, but there are also others. So thanks very much for the support over the past couple of years. So we'll start off just by looking at the challenges. So why manage surface water flooding and why sustainable drainage is a good way of doing that. So the main sort of the first thing to do really is talk about what surface water flooding is. So there's obviously many different types of flooding. Surface water flooding is the flooding which is caused by runoff following heavy rainfall. So it's really crucial. It's basically when the rain saturates the surface, there's nowhere for runoff to go. It overspills drainage systems, and it's a particular problem in dense man-made environments with limited drainage. Surface water flooding has recently been described by Sir James Bevan, who's chief exec or was chief exec of the Environment Agency, as the biggest flood risk of all. This is because it has a significant impact, but also it's less visible and less predictable than other types of flooding. So in terms of surface water flooding in the UK, there's sort of a few key numbers here from different sources. So the first is, at the moment, there's approximately 3 million homes at risk of surface water flooding in the UK. And on average, this causes about £500 million of estimated annual damage. And one prediction places this at about 40% of UK flood losses. And it's sort of a good example of surface water flooding. The photograph there on the right-hand side shows Coverack in Cornwall. And this was a sort of large rainstorm that happened in 2017, and this is what happened to the catchment. So you can see there's significant hazard here. It causes a lot of damage, but it's also very, very dangerous for people and for lives as well. So to think about this in terms of its comparison with other natural hazards, this graph here shows insurance data, which shows the sort of global impact in billions of different economic losses by natural hazard. If we group those natural hazards, which also include surface water flooding, we can say that surface water flooding is involved in about £173 billion worth of annual damages. Now, this is a very rough way of looking at things. But I would also say this is likely to be an underestimate, because this data is based on reported figures and its direct damages as claimed by insured losses. So, so obviously there's a lot of unreported and uninsured damages which also happen. So the bad news is that the hazard is increasing. So we have climate change, which is leading to increased rainfall. And this is going to drive a hazard in a sort of significant way going forwards. And if we look at this specifically to the UK, we can see that we're likely to have an increase in winter precipitation and a decrease in summer precipitation. And what this means is we're going to get long dry periods followed by much more extreme rainfall, which is really going to drive this issue. Now, alongside that, we also have an increase in the impermeable area in cities. So as we pave, we reduce the ability for our landscape to sort of absorb this water. And there's also sort of various economic challenges and challenges in terms of legacy drainage infrastructure as well. So, so this image here actually shows some wooden pipes that they do still exist in some places. So there's a whole range of economic and political challenges which is going to increase this hazard. So the good news is that we do have a lot of solutions to help manage this flooding. So we have established technical understanding of a huge range of technologies now, things like SUDS, conventional drainage systems, so pipe networks, but also sort of water sensitive urban design, green infrastructure. And lots of these interventions have the potential to not just improve the surface water flooding issues, but also to add other natural capital benefits to cities. Now we have a few challenges in terms of applying these. So one is that we have lots and lots of measures. So we have to find ways of deciding how we can compare all these different measures and all the different permutations of measures at a large scale. We have different ways of doing this, and some of the tools we'll present hopefully respond to this challenge. The second key challenge is how we can develop this really, really good understanding and great examples we have of site scale and small scale sustainable drainage through to a whole catchment scale. So catchment management is a really established and really effective discipline in river catchments, but it does still remain challenging in terms of integrating that space for surface water management. And one of these issues is that surface water flooding is transient, it's difficult and it's challenging to predict and manage. So with a river network, it's really easy to see where our channels are going to be, and that helps us connect our catchments. But actually in terms of surface water flooding, it's our towns, it's our cities, it's our landscapes, which don't appear to be channels, but these can become significant channels during heavy rainfall. So we have to find ways of understanding and predicting how these landscapes tie together. And a really good example of this is a case study we'll revisit a little bit later in the presentation. This is actually Elizabeth Street in central Melbourne. For those of you who know Melbourne, this is the very centre of the CBD. So this is a really important area for the finance, the government, a lot of sort of the functioning of the city, and the main train station is in this area. This is what it normally looks like. This is what it looks like in 1972 during something sort of extreme surface water flooding. So it's really hard to identify where these areas are going to be, and it's really important that we manage these by thinking about the catchment scale, because that's where this water is coming from. So I'm going to talk through a few of the tools and things that we've put together on this suite project. The first is looking at something which we call a synthetic stream network. And this is all about trying to connect a catchment and to try and draw together different sort of spatial elements of the catchment so we can understand where risks are and how we can work together in different spaces to manage those risks. So the way that we've done this is we've engaged with stakeholders on our project, on the Sustainable Drainage Suite project, and we've thought about what our stakeholders need to really understand the dynamics of surface water runoff at a large scale. The first thing is we need to have an accessible platform which different stakeholders can access and understand how they connect together. So therefore, we've made sure we've used open access data to generate our products wherever possible. We also need to have this spatial understanding and visualization of how a catchment connects, so we can work with different groups of stakeholders in order to bring people together. And really, there's this understanding that the challenge and the options for solving this challenge are very, very complicated with a lot of different permutations. So it's really important to develop these sort of initial screening steps, which can help really refine and evidence the next steps that we want to take. So the way that we've done this is we've put together a regional screening database. This is essentially a sort of a high-level screening tool which allows us to visualize the flow routes across a catchment. So we start off with just an open access regional elevation model. And what we can then do is apply geoprocessing techniques to calculate flow directions between cells and then the flow accumulation across that elevation model. So this really starts to show us how water is likely to move if it's just purely running off that landscape. What we can then do is we can then define a sort of an artificial, a synthetic stream network by looking at the way that these flow routes accumulate and coalesce across the whole catchment. So it's very similar to the way that water would sort of coalesce as a river network, but what we're actually looking at is we're looking at the towns and cities and landscapes, which we may not see those channels on a sort of day-to-day basis unless we have these extreme rainfall events. And what we can then do is we can look at this stream network and look at the topography of the catchment to identify the sort of catchments and the unit areas where we can manage these risks and the sort of key flow paths we need to manage. And what we can then do is apply a catchment ordering algorithm, which lets us think about how each flow path is connected to others. So a first order catchment would be right at the top with nothing else flowing into it. And then as this catchment order increases, we have a larger number of channels flowing into that. So we can sort of understand different ways to manage it by sort of the order of each channel. So that's the theory. What I'll just talk through now is how we've applied this to Southwest England. So we've taken a regional elevation model. We've got an open access model at 2 meters resolution. There are some gaps, so we've patched this with coarser data, but the aim of this is really to make sure we're using open access data wherever we can. This approach has been applied across the whole of Southwest England. We've just zoomed into, I think this is Exeter here, just so you can sort of see it at a more local scale, so you can see how these steps integrate. So the first step is getting this DEM. The next step is applying this SSN through calculating the flow direction and threshold. So you can see here we're starting to get the surface water flow paths based on our classification there. What we can then do is apply catchments to these flow paths and then order those catchments. So what we get here is a sort of distribution of different types of catchments, and we have this across the whole of Southwest England. And if we zoom out, you can see sort of the scale of this data set that we've produced. So we've got a really good understanding of the sort of high level overland flow dynamics across this area, with some relatively fine resolution elevation modeling underpinning it as well. So what we can start thinking about is what this information gives us in terms of solving this surface water management challenge and how we can target SUDs. So if we come back to this, what we can do is we have this understanding across a whole area, but we can actually zoom in to smaller areas within that. So in this next slide here, we're zooming in, and by looking at the order of the catchment and the type of the catchment and the way that those flow paths are connected to other flow paths, we can start thinking about the sorts of interventions which might be appropriate in these spaces. So for this first example, if we had a first order catchment, so nothing else is flowing into it, that tells us we need to manage any surface water flooding issue in that catchment within that catchment itself. If it's an urban area, we can start thinking about localized water capture interventions and those sorts of things. If we go to sort of a higher order catchment, so a second order in this case, what we can start thinking about is not just managing the surface water issues within that space itself, but also tracing that network upstream. So if we have an upstream rural network, we can start thinking about how we can use localized land management to actually slow that runoff and control that surface water flooding. And if we follow this through to the sort of the highest order catchments, so this 8th order here, what we're now looking at is this is actually the River Exe, and we're thinking about if we have flooding at this space, we have a really large area upstream that we can start connecting and managing. So this is a really good way of splitting up a catchment and really understanding where the risks are and how we can respond to them. It's very, very good for identifying stakeholders, identifying the scope and the scale of data that we need, and really sort of helping to inform the next steps of interventions we're going to look at. So this next tool is using some AI flood modeling. It's called CAFlood Pro, or CADIS 2D. And this is some flood modeling software that's been developed at the University of Exeter. And the purpose of this modeling really is to try and use readily available data to quickly model catchments. And this modeling technique is significantly faster than sort of more detailed hydrodynamic modeling, but it still gives a really good simulation and a really accurate simulation of runoff and flooding and water movement across a catchment. So I'm not going to go into a huge amount of detail with this, but I will say that the CADIS is based on a cellular automata flood model, which is essentially a grid-based structure where we control runoff by thinking about how water moves between adjacent grid cells. And what we do is we parameterize each grid cell with parameters which sort of describe the water balance in that cell. So we have input, which describes the sort of the rain falling into the cell. We have output, which can represent the infiltration rate or the drainage rate or anything removing water from the surface. We have an elevation parameter, which describes how sort of high that cell is and slopes between that cell and others. And we also have a sort of roughness coefficient, which describes sort of how sticky that cell is and how it holds onto water. So it's a relatively simple set of variables, but it does allow us to describe a huge range of different land use types and interventions if we're quite careful about how we parameterize those. So for an example, if we'd like to think about how we're going to represent interventions within this modeling framework, if we adjust that input parameter, what we're doing is we're changing the amount of water that enters the cell. So this is a good way of representing interventions which are actually going to capture rainwater as it falls. So this sort of cutout here just shows a rainfall event over time, so the intensity increasing over time, and then what we can do to that rainfall event to represent different amounts of rainwater capture within a particular cell. On the other hand, if we want to represent changes to surface drainage, we can think about how they influence the roughness and also what that will do to cell output. So whether we're going to have a very high drainage rate and a high cell output, or whether we think that we won't have that in case of some areas. So ultimately, this is just a really good way of taking the information we can screen with our synthetic stream network, and then putting this into a framework which then allows us to take the high level data from the areas we've identified as being promising for managing surface water, and then representing the study area, representing that area using the sort of readily available data at the start of the project to develop, design, test and explore different interventions, rainfall events and strategies. What we can also do is take this exploration and this flood depth we get from this approach, and we can apply it with flood depth damage models. So we used a model called Corfu, which was developed through some EU funding at Exeter a few years ago. And what we can do then is we can look at the flood depths, we can look at buildings and features across a catchment, and we can apply cost damage functions to those and calculate actually what the damage or predicted damage will be for particular types of events with particular types of interventions. So to sort of summarize the rapid scenario screening element, it's really well suited for strategic decision support particularly at the initial stages of design and consultation. So it's very good for exploring different scenarios, identifying those sort of promising strategies early, which allow sort of further work on those. It's really designed for preliminary analysis and really taking that readily available data. And it's all about evidencing and supporting next steps. So by exploring the catchments and exploring the different options which might solve surface water flooding, what we can do is we can indicate our additional data needs. We can sort of direct and refine any sort of modeling requirements and detailed modeling requirements using the really good tools and the really good understanding that are already widely available. And we can also think about identifying stakeholders and the sort of spatial relationships across catchments to engage and hopefully solve these issues. So what we'll do now is just talk a little bit about how we've integrated these approaches in Devon during SWEEP. So this really is a case study we worked with the West Country Rivers Trust to look at, where we applied the SSN to understand flow across a catchment, and then we applied RSS to sort of understand the sort of strengths and limitations of different types of surface water flood intervention. So here we have a catchment in Devon, which it's predominantly a rural catchment, so the runoff's a really important aspect of that. But there are also quite a lot of houses and a lot of people live in this catchment as well. The first step, which is just shown on the right-hand side of this slide, are the relationships between different surface water flow paths and surface water catchments across the catchment. And you can see there that they sort of, some of those catchments drain towards a river, others sort of drain through properties as well. So it's important to manage these. And by taking rainfall data, by getting the elevation models, what we could do is we could simulate flooding across this landscape, across a huge range of return periods and durations. So here we can show you the 3-hour and the 1-hour flood through a 10, 30, 100 and 1,000 year rainfall event. And this graph just shows the extent of pluvial flooding, of surface water flooding during those events. What we could then do was take those flood risks and take the number of properties which flooded and develop a flood risk impact score. So this flood risk impact score is all based on the number of properties which flood, the length of roads that flood, and also the area of agricultural land which floods in different scenarios. So I think this is based on the 100-year event. And then through applying the RSS, we're able to actually develop these sub-scenarios to manage that risk. So here we look at the influence of target storage ponds there on the left-hand side. So we can see that by applying targeted storage ponds, we start getting a benefit of reduced flooding downstream from those flow paths. And we can use our SSN to actually design where we'd like to put those ponds. We also looked at rainwater capture, and we could see again in that middle graph there that we're getting a sort of a modest reduction in flooding associated with areas downstream of the rainwater capture. And the really positive thing about that is often we're capturing rainwater from properties, so we're reducing the rainfall, reducing the flood depth directly around those properties. And then the final sort of diagram on the right there shows how improved soil management affects this area. So we can see we're actually getting some fairly significant runoff reduction through really strong soil management techniques. And what we can also do is we can sort of integrate this, this catchment approach and this sort of surface water subcatchment approach with other natural capital analysis techniques. So this is a different catchment, again, working with West Country Rivers Trust, where they've taken the surface water catchments and used it as a sort of foundational unit for thinking about how particular infrastructure will also have effect on other things. So we're looking here at materials, crops and livestock, air quality, climate regulation, and also cultural and historic values. So this is a really nice way of being able to integrate the benefits of different green infrastructure from a perspective of managing surface water flooding, but also realizing other natural capital benefits when we do that as well. So that's the sort of, they're the sort of main areas that we've worked on. But one of these key questions that we really want to approach, and one of the things that hopefully will make surface water management much more effective across the UK and hopefully globally, is thinking about how we can take this really good understanding and these really good examples of SUDS projects, which happen on a smaller scale and a site scale, and really move this forward towards regional surface water management. So what we have here are just a few examples of how we can upscale this methodology. So the first is looking at an urban catchment scale. So this is a small catchment in Exeter, and we've applied these approaches to think about the estimated annual damage of flooding in these areas. And what we've done is, for this particular study, because it's a relatively small catchment, we're actually able to look at, I think it's maybe 8 or 9 different strategies applied in different permutations across, I think it's about 11 areas. So in total, we've run about 800, in total, there's about 90 different permutations there. And we've evaluated these permutations across, I think, about 10 different types of return period. So we end up having sort of 800 evaluations of different types of strategies and types of rainfall event. So it really allows us to explore different surface water flood risks and how they, and different interventions and how these respond to different conditions in a catchment. So yeah, we'll go through that. What we can then do as well is we can take that small urban catchment and we can look at a city scale. So this is application in Melbourne in Australia. And if you remember the slide from the beginning where I showed you Elizabeth Street in 1972 flood, this is the catchment which controls that. So we identified the main flow paths which flow down towards Elizabeth Street. They're just sort of shown as transects there on the far right-hand side of these pictures. And we started examining how different flood management techniques might influence the runoff through these flow paths. So we looked at a range of different approaches at the city scale, and we applied different flood events. And what we were able to do is actually think about how the distribution of flooding changes in those key flood paths during different types of events. So here, this is a 20% annual exceedance probability, so sort of a 1 in 5 year event, and we can see the peak flood depth through each transect. And then what we can actually do is see how different strategies, so the strategies are there just on the x-axis at the bottom, will change the flood distribution against the baseline, which is the sort of far left-hand side distribution. So we can see this for a 20% event, and we can actually slowly increase the flood duration and the flood intensity to then see how different strategies perform over different ranges of events. And then the final scale is really thinking about this at a landscape scale. This is the San Francisco Bay Area in America. This is a huge study area. I think it's about 60 by 200 kilometers. And we developed a model of this. And we're actually able to look at this sort of regional scale flooding during really large events. So there's 100, 200, and a 1,000 year event there, and really understand how different landscapes connect at a sort of broad scale to then start thinking about how we can prioritize and refine our investigations at a next step. So to sort of summarize this, what we've really tried to do here is move from a sort of a site scale approach towards a regional scale surface water management using sustainable drainage. And what we've done is we've really wanted to explore the surface water dynamics at a regional scale to sort of bring together stakeholders and bring together understanding and identify opportunities. And we've created this synthetic stream networks tool to do this. We've also wanted to evaluate the many different opportunities we have. So we've applied a rapid scenario screening approach. And we've been able to use Sweep to support taking some of that research that's happened at the University of Exeter and actually working with different stakeholders. So in particular, the West Country Rivers Trust for that particular exercise, to actually apply some of this knowledge in practice. And the key thing that we're trying to achieve with all of these methods is to sort of evidence the next steps and really support decision making. So identifying the scope of challenges and opportunities in catchments and landscapes, engaging stakeholders and finding new ways of presenting information to them, an early stage of design so we can get people to work together with the sort of other tools that we might have. And then also to really evidence, direct and refine the detailed requirements we need for modeling, for data, for promising interventions that we might want to explore, and really try and tie this together for decision support at a later stage. So we try and make this sort of information as open source as possible. So if anyone would like to sort of discuss this or think about collaborating with Sweep to try and bring some of this research into practice from your own perspective, then please do feel free to send me an email. My contact details are just at the bottom of this slide. And there's a whole sort of range of sort of surface water flood dynamics work that we're doing at the moment. So thank you very much for your attention. I'm now going to pass you over to Jonathan.
Now to do a little bit of adjusting of our amazing facilities we've got here. Right, thank you very much. My name is Jonathan Hubbard. I'm the senior site drainage analyst at Pell Frishman. I literally came into this Sweep project with James probably a little bit at the tail end of it. A little bit unfortunately, the information that James actually collated and everything could have been quite useful on the case study we're going to actually have a look at. So if we kind of look at this one, this is a case study of Kingsbridge, which is a town, the South Devon coast, at the head of an estuary. Unfortunately, this poor town has about 5 watercourses running through it. These 5 watercourses in the past have been very useful, as it was actually a milling town that actually made gloves, and they used the natural water resources to run the mills. Hence that the watercourses were actually very heavily moved around by man and shifted over time. So what we were looking at here, we were asked by South West Water, Devon County Council and the Environment Agency to look at the flooding that was actually occurring in this catchment. To do this, we created an integrated urban drainage model, which means that we took the sewer network and we actually then took the watercourses and we created a model where both of them will interact with each other. So this was actually to try and tell us what was actually causing the flood. Was it tidal? Was it fluvial, or was it the sewer network that was causing most of the actual problems in this catchment? And then provide a cost-effective engineering solution. So how do we kind of go about this? If we move on, and hopefully we'll run this lovely little video that will show you. So what you got on the left-hand side is, if you see, that's James's output from his modelling. So he's doing the flow order. On the right-hand side is actually the hydraulic model, just running flows over the surface. And those arrows are showing where the directional flow is actually going. As you see, it gets rather a bit messy after a while. There are other things I could do to make it look nicer and prettier, but it gets pretty confusing what's actually going on there. The great thing, stuff that James has actually done, is actually tell me roughly where the critical flow paths through the actual catchment actually is. But also he's ranked it. It's one thing you can't do in hydraulic modelling. It's like going, well, which one really is truly the major one that's causing me the most problems? James has already done it for me. That's great. And I wish I'd actually had this data right at the beginning of my modelling, because it helps me make informed decisions over how I want to go about doing this model. So if we kind of move on to the next slide, what we've kind of got is we're just going to compare what James's output is slightly against what is actually on the ground here. So in the pink and the purple, you can't see James's flows path and ranking, and then you can just see about the blue lines as well, which represent the actual watercourses. As you see, it's quite patchy on watercourses because, of course, they are actually culverted. So if we can't move on and actually now say, well, actually, what was actually there? So the red lines now actually show where the watercourse actually runs, including where it's culverted, and you can't see where the watercourse is going. And all of a sudden, James's data is coming a little bit more in line with what we're actually expecting. It's still out. It is one of the problems with when you get down to these catchment levels of how it gets altered by man over time. But even though man has moved the watercourses, the flow paths still remain the same. So these flow paths are actually the exceedant routes for the flow. When the watercourses become overloaded, when the culverts can no longer take capacity, this is where it's actually going to go. Weirdly enough, on that page, sorry, I can't clearly point it out to you, this data actually told us that there was another culvert that we didn't know about. And because we had that data, we kind of went and investigated that area and actually found it an uncharted culvert that nobody knew about. And we were all wondering why it was all flooding and everything until we found out somebody had actually driven a very large concrete post straight through the culvert and was causing a bit of a blockage on it. If we now move on from the reality, and we can't get to the final output. So again, we got James's output on the left-hand side, and you kind of got the model on the right-hand side. So if we run the video on this, I'm going to very boringly show you that what's happening here is, as the model is running the simulations, this is the full integrated one, you'll start to notice color will start forming on top of the mesh. This is actually indicating the flooding that's actually occurring. And oddly enough, what starts actually happening and what it should actually predict, it actually predicts exactly what James's data is actually saying. This is the flow path. This is the where it actually wants to go. There are some minor differences, but in the whole, 80% to 90% of it, it actually matches what James is actually putting out. So what benefit is this of what James kind of gives me as a modeler is I kind of can take this initial data and I can say, I can see a watercourse to the west. That seems to be my dominant flow. That is where I might want to start concentrating my solutions. Perhaps I need to control the flows upstream. Unfortunately, in this case, if you notice to the west, there's a very large blob has formed. That large blob is there for a reason because somebody in years past has just been as clever and he's actually controlled the flows of that watercourse entering into the town. They've actually got a flow control device there. We didn't even know about it. The Environment Agency didn't even know about it, and we just came across it. That is actually controlling flows. That's where we wanted to put an actual pond, and it's actually already there. Similarly, another thing that we found with data that James was actually generating was this thing we understood exceedance routes. Where does the flow actually want to go? And do we need to put in mitigation measures to slow that flow up to protect properties along those actual lines? And we've also kind of had to think about this in the future is this is just on one little catchment, but James has done it globally for the whole of the Southwest. So with some very clever little GIS like querying, you could end up actually saying, well, where are these these actual exceedance flows actually going? What are they crossing? What are they interfering? Are they going to flood across a major route? Are they going to actually impact on a pumping station or some other critical facility that could actually cause problems? So this is where we're kind of going to. So we're actually quite excited about this data. We're so excited actually, we want James to actually look at a completely different area outside of the Southwest, where we're actually doing modeling at the moment for a client to do a similar kind of like exercise of looking at criticality. So one thing I kind of learned with James, he's mentioned caddies and Corfu. That's another tool we would like to actually also use. And we actually found the whole suite project is actually really quite useful to our company. as James has opened doors to us, to other people are doing really interesting work that we can actually see has some additional benefit other than what it was originally created for. So I'm not going to bore you anymore. I think we're now going on to our Q&A session. Thank you for listening to me.
Thank you both, James and Jonathan. That was really, really impressive piece of work. Yeah, it certainly makes me think, view catchments in a different way. So we've got a number of questions that have been popping up in the chat, and I'd really like to first of all give Anne Skinner first opportunity to pose her question. Anne, can you please put yourself on mic and on camera?
Hi. Given that SUDs are not mandatory, we've got a government target of 300,000 new houses a year and a proposed reform of the planning system. An imperative really is embedding this way of thinking into local authority decision making. And I was just wondering what SWEEP was thinking of doing about that, across the country, really. Thank you.
Hi there. I think that's a brilliant question and a really, really crucial point, really, which is hopefully steered us down this research route from the beginning. We want to build a lot more houses. SUDs, SUDs are a large part of the solution in terms of managing our runoff and managing our surface water dynamics as we increase the impermeable area. But I think probably what happens a lot of the time at the moment is that we tend to think about SUDs and about sustainable drainage on a site-by-site basis. So we would really like to see a movement towards a sort of a regional catchment perspective. And what we might find is by using tools like this, we might find that at the moment, if a housing developer puts houses in, they would probably maybe put an attenuation pond or a SUDS treatment facility on their site. What we might find is actually by integrating our catchment understanding, there might be more cost-effective ways for the developer and more beneficial ways for the community to actually manage water off-site by thinking about how the connections across the landscape sort of coalesce. That's the sort of thing we'd like to do. Really, I think where SWEEP has come at this from, to answer the second part of your question, is at the moment we've sort of recognized there's this need and we're trying to develop tools and case studies to show that. I think for this particular part of the project, we haven't looked at trying to put this across the whole country, or haven't looked at trying to sort of put this into policy just yet. But it's definitely something that we're sort of tracking the success of what we're doing at the moment and thinking about for the long term.
Lovely. Thank you. I'd like now to give David Smith from South West Water an opportunity to ask you both a question.
Hello, Jonathan. Simple question, really. So you really focused on the urban in your presentation. The question is really, have you thought about how you could apply this to rural water entering the combined sewer network and then reducing the impact of those storm discharges that go off when that happens?
What we can actually find in some of these areas is the actual impact on the CSOs. Oddly enough, it is not as big as you kind of think, generally because the CSOs are discharging into watercourses or surface water systems. So they tend to actually end up being slightly locked, so they can't actually discharge. What the problem with them not discharging is that they end up, of course, causing flooding. And we have this situation actually in Kingsbridge. We have a CSO, every time the tide comes up, it can actually kind of become quite tide locked. And the kind of water can rise quite rapidly in the combined system and then flood out of some of the chambers. Similarly, I kind of understand that, some of this runoff, yes, we would like to try and see terms of, can we look at reducing the combined runoff from the surfaces going into the combined system? It's not unusual to find housing that has actually technically been built with a separate system, actually now receiving runoff from storm events. So we can actually use this type of modelling. Has told us how those CSOs are actually functioning, And yes, there is a certain degree where we want to actually remove some of that flow out of the catchment getting into the actual combined sewer. Hopefully that's answered your question.
Thank you. Yeah.
Could I just sort of add something to that as well? So in terms of this, you sort of mentioned that sort of how effective this is across the rural areas. One of the things that we were thinking about at the start of the project is it's really important to understand the whole landscape and how it connects for managing surface water flooding. And actually this data set, as Jonathan's example was brilliant in terms of an urban area, but this data set connects across the whole Southwest, connecting rural and urban areas. And in some ways, it could actually be considered stronger across rural areas because some of the other sort of urban drainage features in cities aren't as apparent. So therefore, this runoff is even more sort of accurate. So it's definitely a data set which works across the whole sort of combination of different catchment types.
Great, thank you. Yeah, moving on to Mark S. Mark, can you put yourself on camera and on mic, please?
Hello. Sorry, I can put myself on mic. My camera's playing up at the moment. Can you hear me?
Yeah, we can hear you okay.
Great, yeah. Mark Summers, I work with the Catchment Partnership in Cornwall. And my question is around, when you look at a wider catchment and the fields in the areas above a catchment, the soils, are you able to model the actual against the theoretical capacity of those soils to attenuate water? And if so, can you model it in such a way that it could be used to support funding bids?
So I think there's sort of, I guess there's two perspectives to that. The first is with the SSN approach. That in itself is a very high level looking at runoff as opposed to capacity of the soil. So we wouldn't try and use that for that particular approach. The CADI's 2D modeling, we can parameterize it to represent different infiltration rates and different storage rates across soils in an area. It's not something we've done, but it's definitely achievable using that modeling framework. Yeah, I think in terms of actual versus predicted, we can definitely do the predicted side of it with CADIs. What we would need is data which actually shows what is happening in practice for us to compare that against. So I think this is probably one of the big issues in surface water sort of analysis and surface water flooding, is actually trying to find really good quality data to validate surface water modeling. And I think we're really good at this in terms of river catchments, because we can see the flow streams, we can see the channels, and we know where to put gauges to really accurately measure that. But in terms of surface water, where you can see the sort of the flow paths spring up, and it's very difficult to predict in advance where those flow paths are, it's hard for us to get really good, accurate gauging on catchments because we don't know where to put it to start with. So if we could easily, or we could definitely predict these things, and then to actually we'd have to find a new way of getting data, or if you have data, that would be an interesting conversation to have to work about trying to validate this against the sort of things you're saying.
Yeah, I think it's one of the challenges for working with natural processes, actually. When you compare working with natural processes against that's inverted commas conventional flood flood risk management, conventional engineering, it's you're working with absolutes. And if you could an area of soil, a large area of soil, and communicate its theoretical capacity and work towards that, it might be easier to build into the suite of measures support say, conventional investments.
Definitely, and you definitely get the sort of larger natural capital benefits from applying these sort of natural approaches as well. One thing I sort of didn't mention, which I really should, is scale is really important in terms of these modelling approaches. So the modelling that we've presented today is really designed for this catchment screening initial sort of preliminary analysis across a catchment. The best way of modelling the sort of soil flow rates is probably using some, particularly if we're looking at a smaller site scale, probably using some of these really sophisticated groundwater flow models that that exist. So we could definitely support it with the sorts of things we presented today. But I think there are probably more detailed approaches which would hopefully give you a better answer.
James, I'm just going to jump in a little bit. I've tried to actually model site soil dynamics and everything, and there is a severe lack of data to actually help you to actually put your model prediction against what's actually happening. And we have actually found there is some peculiarities sometimes happen when we do have temporary boreholes in. We did have one that done something very strange, and then we found out that actually it was the water company down the road had was digging a new pipe, and he was pumping all the groundwater out because he's dewatering, and suddenly our borehole gave us some very old data. But at the moment, I think there's just not enough borehole data or soil. There's not a good enough coverage across even the UK to actually give us a good idea of how how the soil mechanics are actually happening. But it is you can model it. It can be done, but it is. I would like to actually put my predicted against something that's actual.
Yeah, clearly there are some challenges there, and this is something Anthony Firth also raised. It's some interesting challenges around doing the work that you're doing. Anthony, are you there? Can you switch on your mic and your camera?
Yeah. Hello. Hi. So yes, I was interested in the points you were making about looking at the connectivity of the whole landscape, but also the points also that Jonathan was making about historical interventions by people in watercourses. So I just wanted to flag the fact that we've been modelling human interventions in watercourses at catchment scales, including the River Culm. So we've looked at the whole of the Culm and basically flagged all the evidence for human interventions that we can find. I just wondered whether that might be a useful conversation to have at some point to compare your modelling with the kinds of things that we're seeing and flagging, because I think there might be some causality we can see there between essentially systems of water management that have been neglected or ignored and have fallen into disuse on the one hand, but also some causality on one side in terms of challenges, but also some opportunities on the other in terms of rejuvenating those systems where there might be opportunities to do so. So I think it might be interesting to have some conversations about how these data sets might complement each other. Thanks.
I was just wondering if that's kind of on the lines of, sorry, going back to Kingsbridge, as I say, it was kind of like a mill town. What wasn't very clear on my plans, it actually had two leads that came round a promontory. So they kind of intersected two different walk courses that came round. And then there was like a big drop where they had a big water wheel, and that water wheel no longer exists. And one leap has actually been disused. And we're like going, well, can't we actually use that as a, to feed off of that and actually use that as a, almost to send divert flows around the town and drop it back down. And we're like going, and then couldn't we actually then put something like, a turbine in that would actually generate electricity to actually then fund the actual project to put the old leak back in? And, you do get quite,
Absolutely.
Man has changed so much.
So certainly worth recalling that all the industrial energy in the southwest, other than perhaps animals, was from water energy. So that's huge potential there. And so absolutely, there's people were doing that until very recently. Why not look at doing it again? And I think there's a lot of opportunities there in connectivity, restoring connectivity, and so on. I mean, we're seeing it particularly in the extent of leaks on the Culm for milling particularly, but also agricultural uses, so past agricultural management, so the use of catch works and bedwork water meadows and so on, which have fallen into disuse and are probably having quite an effect on runoff now, but perhaps might have the potential for some level of rejuvenation.
I mean, there is this thing with, okay, sorry, I'm going to probably hog a little bit, but like Kingsbridge, you talking about water meadows, and I tend to get a bit worried because we had some very odd flooding in Kingsbridge that we couldn't really understand why it was actually occurring there until we went to the town council. They were absolutely brilliant. They were a big source of information for us. And one of them said, well, that's because it used to be one of the mill ponds and they went and built a load of houses. And we go, right, that explains that one. Thank you very much.
I think you'd find lots of instances of that kind of thing.
Great. Thank you very much. Thanks for your question, Anthony.
Thank you.
So just time for one more question, and I'd like to hand the floor to Finn Duncan. Finn, are you there? Can you put yourself on mic and on screen?
Hi. Hear me?
Yes.
Good. Yeah. So I was just basically querying the fact that these future flood events, events is probably anecdotally becoming less of a 1 in 100 year event and more of a 1 in 20 year event. And in terms of looking at the models, has UK CP18 and other kind of new forecasting climate projections been included in with these models?
So in terms of, I think it's a really good point that actually our understanding of what is a particular return period is rooted in historical data, which we know at the moment is changing pretty rapidly. If you look at a lot of the projections, so we haven't tied our modelling to any particular rainfall or climate projections, because what we can do is we can actually, when we're generating these flood depths, we can put any rainfall we want in those. So when we're looking at CADIs, we can select the rainfall data with our partners, which best describes what they want, and we can put that in. What we've done in the past, which I really like, is rather than just running 1 or 2 events, we've used the fact that CADIs is a really fast model, so therefore we can look at a huge range of possible futures, rather than just tying ourselves to 1 or 2 scenarios, which is why we sort of sacrifice some of the detail in order to get this sort of exploration of what might happen. And in terms of rainfall, one thing we've done in the past is we've designed interventions for a catchment, and we've sort of stress tested them independently of the probability of the rainfall happening. So we've looked at what will happen in a critical storm event, and then we've just gradually increased the magnitude of that storm. And we can sort of see the cutoff point for where interventions become effective and which interventions are better for different ranges of rainfall. Then we can tie that back to the projections, and we can start understanding as to sort of where that fits in terms of the return periods as well. So yeah, there's sort of a range of things we can do, and I think the advantage of these sort of screening approaches is that we can look at lots of different futures and lots of different options.
Lovely. Thank you very much for everybody's participation this morning. Thank you very much, speakers, for James, Jonathan, great presentation. I noticed there's a lot of chat, a lot of chatter going on, some comments about the various bits of work that we've discussed. We'll certainly filter through that and act upon that. Thank you very much. So we're just going to go into a short comfort break, and we'll reconvene at 11:45. That's 11:45. We'll see you then.
Thanks, Ross.
Hello, everybody. Welcome back. This is part 2 of the catchment scale management approaches to natural capital restoration and protection. Okay, I'm your chair. I'm Ross Brown. We'll be really entering into a series of rapid fire presentations in just a moment. I'm going to start, then I'm going to hand over to Nick Paling. He's Head of Evidence and Engagement at West Country Rivers Trust. And then we're going to then pass on individually, each of us, to the following speaker. David Smith will follow Nick, and then Sue Pritchard, who is from the Food Farming and Countryside Commission. She will then follow on from David, and then we'll have Paul, and then we'll have Rob. So we'll basically be talking in quick succession. At the end of each of our talks, we've got a multi-choice question, and the previous speaker will introduce that question, and then we'll allow you to provide your answers, and then we'll present the answers to you on the screen. So yeah, I'm going to just begin. So yeah, this is all about future scenario setting for modelling water quality for aquaculture. Aquaculture is a very sustainable source of food production. It includes shellfish and seaweeds. But as with every form of aquaculture, it's really dependent on good water quality. And that's because, shellfish, for example, can filter large volumes of water and accumulate contaminants from that water, meaning that the food isn't fit for human consumption. And also these contaminants can also affect even product quantity, affecting shellfish growth. So it's important to look back up and take a whole catchment approach to water quality management, because many of us can have an impact on that. So yeah, water quality is absolutely important, and it's a really good indicator of good land use management and ecosystem health. So if we have, buffer strips around farmyard fields, we can protect against material entering into those watercourses. Equally, if we have efficient treatment systems for effluents, that can have big impacts, positive impacts on water quality. And here we're thinking of microbial water quality, contaminants related to fecal material, but also chemicals that are leaching from various different land uses and effluent inputs. And these can all make their way into the watercourses and into shellfish, for example. Here you can see shellfish being harvested in the X estuary. But of course, water quality is required by a number of downstream stakeholders, including wildlife. We've got extensive populations of birds in our estuaries. We've got lots of people using the water at the coast. We've got residents and also big streams of tourists moving into the area to use this. We have water abstraction, and all of these things require good water quality. And water quality is being impacted. You may have noticed, it's been in the news recently, covered in all the major newspapers, that all the rivers and lakes in England have failed to reach good chemical water quality status under the Water Framework Directive. And these impacts, they come from municipal and industrial and agricultural sources, and they include chemicals and they include microbial contaminants, including coliforms. The impacts are further exacerbated by flooding and increased land runoff and sewer overflows. So clearly, land use planning and management will be key to delivering clean and plentiful water, which is this vision that we have under the government's 25-year environment plan. And there are numerous environmental stewardship schemes, in addition to the upcoming ELMS schemes, that have benefited terrestrial habitats and water quality. And we can see evidence of that. So for every £1 spent, we see a much greater output in terms of benefits for natural capital and ecosystem services through things like the countryside stewardship scheme, forestry creation, forestry management. Yeah, we also have other examples. So catchment sensitive farming, for example, has created nearly 500,000 hectares of buffer strips around watercourses, and this has reduced pollution losses considerably. We've also got initiatives from South West Water. We've heard about upstream thinking in some of the previous talks, and through that initiative we have the restoration of extensive areas of wetlands in Exmoor, and also this has had a massively positive impact on reducing peak flow during flooding. So yeah, these are all good things, and we, in order to target interventions and mitigation really effectively, we can develop models, integrated catchment models that can actually help us look into the future, look at conditions in terms of land use, precipitation, soil infiltration rates, and hydrological linkages throughout catchments to make predictions about where is best to manage flood risk and to manage the inputs of these contaminants. So we obviously acknowledge that flood risk is a key important factor driving water quality. And we can look to the UK climate projections from the Met Office, and we can see how that increasing temperature, climate change can be linked to increasing flood risk for these various scenarios. So if we look ahead into 2050, we can see that the percent chance of increased flows ranges between 10 and 100% based on different levels of warming. And that also translates into runoff from best, most viable agricultural land, where these changes can vary between 20 to 100% increase in flood frequency. And we can factor these into our models, but what we really need is a view of what land use might be like in England and in Southwest England in particular in the future. And we have obviously a good picture of where things are at the moment, and farmland is a big component of the landscape. Upland, woodland and wetlands are growing. In some cases, urban land use is also in demand. But we can look to recent trends maybe to give us some picture of perhaps what the future might look like. And we've seen some positive trends for woodlands, but that's been combined with increasing urban land use. And arable land use over England has declined, as has grassland, but actually in the southwest, arable land has actually increased. And you can see this from this land cover map from the Centre for Ecology and Hydrology. On the right-hand side, you can see 2019, the kind of increased area of dark red, which indicates the agricultural arable land. So without further ado, what I'd like to do is just ask you now, as stakeholder participants, which of these following scenarios is most likely, do you think, in the next 10 to 30 years? Do you think it would be intensive growth in arable land use, including pesticide use, or do you think perhaps that growth might be accompanied in a more regenerative growth without necessarily massively increasing pesticide use? Or do you think there might be growth in energy crops and solar parks? Or do you think things may simply not change from the current baseline? So we're just going to gather in your views as you poll, and then we can look at those results in a moment. So we're gathering, the votes are totting up. We've got about 50% at the moment. See if we can reach 80%, and then we can show you what we've got. Thank you very much for participating. We're going to show those results now. Okay, so this is really useful. Thank you. Obviously, it's your opinion, but we very much value it, and we're going to take that and move on to the next presentation, which is Nick Paling from West Country Rivers Trust.
Good morning. My name is Nick Paling, and I'm delighted to have been given this opportunity to give a short presentation on catchment-based approaches for water quality management. The core challenge of catchment management is the question of how we can achieve a truly integrated, holistic, adaptive and collaborative catchment management approach, a truly catchment-based approach. As early as 2005, this work was being done in America looking at developing a cycle called the adaptive watershed management cycle, and some researchers and practitioners in the UK adopted the pencil sketch of the watershed management cycle and adapted it into the adaptive catchment cycle that we use today. And the strengths of this process are clear. It's genuinely about co-production of knowledge, collaborative planning, co-design and co-creation, and co-delivery of environmental management. And this work was initiated under the Rural Economy and Land Use Programme but then was built upon in 2011 through the Strategic Evidence and Partnership Project, which was a DEFRA project working with rivers trusts, water companies, the Environment Agency, and at that time, in 2013, when that project came to an end, it coincided with a real need in river basin management planning for a more collaborative approach, catchment management approach, to be adopted. And so the catchment-based approach was instigated through the policy document that was published by the government in 2013. And so the catchment-based approach, is comprised of 104 catchment partnerships operating across England and cross-border Wales. And the work of the partnerships has been reported and evaluated over since it started. And you can see these reports on the catchmentbasedapproach.org website. And indeed, this work has recently been published in a paper in Environmental Science and Policy. More recently, since CABA was initiated, we have been working with DEFRA to align, to map across the adaptive catchment management cycle to the natural capital approach, and they are hugely similar, and there is huge potential for the natural capital approach to become a key strand of the adaptive management cycle. And building on that, working again with DEFRA through a project called the Local Action Project, we have continued to do research and investigation to optimize the adaptive management cycle, so studying in detail each stage of the adaptive management cycle to ensure that it is robust and it's delivering outcomes and impacts that we desperately want to see in our catchment management work. And perhaps most importantly of all, we've been looking at what are the enabling conditions which this approach is built upon. So how do we influence the policy, get the funding in place, build consensus and a shared vision, and indeed motivate and empower participants in the process to take action. So in the most recently, we've tried to take this on even further, which is to look at how the catchment-based approach, can help deliver truly water resilient communities and water resilient landscapes. And we've done quite a lot of work looking at how the elements of the natural water cycle and the human water cycle interact with each other, characterising not just the natural capital assets and the ecosystem services they provide, but also studying in detail individuals and communities, and most importantly of all perhaps the environmental infrastructure that connects the two systems together. Finally, we've been looking to try and build on that model to try and answer this question: how do we help build water resilient communities for the future? And we've identified 4 key building blocks or pillars of water resilience and climate adaptation. And really the catchment-based approach really is encapsulated in this, which is a catchment-based approach is a whole system approach. It does include the creation of social capital, the co-production of knowledge, and the scrutiny of evidence to develop strategic and informed action plans. And of course, it involves the creation, management, restoration of natural capital assets through creation of nature-based solutions, conservation management, and environmental management more generally. And so it's through the combination of these 4 elements, because obviously funding is critical as well. It's that we believe that we can genuinely adopt a catchment-based approach to deliver water resilient landscapes in the future. Okay, so apologies, I'm probably really loud now because everyone's turned up the volume, so you might want to take the opportunity to turn the volume down again, otherwise I'll be deafening. It's not like me to be quiet usually, but we have also after my talk, and so it's a simple one, which we'd like you to vote on, which is simply: which sector do you represent? Okay, so the votes are coming in. Half of you have voted. I'd like to point out that I'm joining you from my personal drone above the Blackdown Hills in East Devon. So, and the view is lovely, despite the fact that it's actually raining catastrophically. %70 have voted. 75. God, this is quite exciting, actually. Right, so we'll probably call it there. It looks like the votes have dried up, so we'll show you the result, which should be on the screen now. Yep. Yep, it's a good cross section. It's a good cross section there. Obviously, might expect that result, but it's good to find out what the cross section of the participants and the audience are today. And so, without further ado, I will shut up, and I'm going to hand over to David Smith from South West Water, who's going to be giving a talk about upstream thinking. Thank you.
Thank you, Nick. Beautifully succinct as always. So I'm David Smith and I manage South West Water's catchment management programme. Upstream thinking, we've heard about it today already. And I've been involved since 2006 when the first pilot started, the Expo Mines pilot. So the next slide, sorry. The current situation in the Southwest, in line with the recent WFD reports, is actually not great. So we have multiple challenges from the farm landscape within that. Shown a few on the slide. So we have farmyards infrastructure that's not fit for purpose. So that slide illustrates some of the issues there. Nutrients escaping, potentially chemicals, pesticides escaping from farmyards. Combined with that, we have agricultural productivity and intensification increasing across the area. Bigger tractors, four-wheel drive tractors, soil compaction problems. I've tried to illustrate that with the picture in the bottom right. All of which leads to top right, muddy rivers, and I can report that it's been raining all day in Blackdown Hills today. The combe actually does look that colour, and it's at the top of the bank as well. So potentially there'll be flooding down in where it joins the X later today. The other issues are, of course, the peatlands, and I showed the peatland in the last slide. So what do we want to get to? We want to get to peatlands that are functional rather than being dried out from past management practices. And we want to get to farm landscape, and as I put there, a paradigm shift in the farm landscape to completely change the way it's managed in terms of water infiltration and also cleaner flows out of that farm landscape. Within this vision, both landscapes can provide food and other multiple services. So I want to make that clear. I'm not advocating that we don't also think about food production from these landscapes. So upstream thinking, for the last 10 years, it's focused on these two outcomes I've just talked about, cleaner water and sustainable flows. And the critical thing about upstream thinking is it's an advisor-led delivery program. The advisors bring about the change in the catchments. The second thing is the farming sector needs to come to upstream thinking with a good plan. So what we're not in the business of is propping failing farm businesses up. They need to have a good plan for the future and a sustainable business plan for the future. And the third point is it has to be a flexible approach. So our grant schemes can offer many things that the other grant schemes you're going to hear about later in these talks can't offer. And also we ask the farmer to commit as well. So it's a co-commitment. So they have a vested interest, and that links back to that good farm business plan. So the South West Water vision is expanding the upstream thinking approach from out of the drinking water catchments, which are shown on this picture, and I showed it yesterday, across the whole landscape and for multiple outcomes for South West Water. So the little dots you can see here are sites where we have potentially need schemes to reduce nitrogen or phosphate emissions from our own water treatment works, and we could achieve much more reduction in those same nutrients through working with farmers. So that brings us into the sphere of nutrient trading in the landscape. So those are the principal new drivers for us going forward. And we also talked earlier about stormwater flows and discharges. But just thinking about those 2 new delivery areas, we can deliver across the whole suite of ecosystem services, even though we're focusing on those 2 additional areas, and including drinking water, of course, in that. So there's a real opportunity to improve the range of ecosystem services that this landscape can provide across our interests as a company as well. So that's it from me, just to flag up. Thank you very much. And I did mention this yesterday as well. We have this new 5-year report out, which will be on South West Water's website soon. It celebrates the last 5 years and looks towards the current programme we're in now. Right, so my questions. So what is the best use of the uplands in the southwest? Bearing in mind we have climate change and we have population and economic growth in the southwest. But as I said, in my vision, we can provide food from this landscape, and we can support rural communities and populations in this landscape. So what's the best way of doing that? Ross, can you help me with this? I haven't mastered how to find the poll. I can't seem to find it on Zoom, and how to count people's votes up. Just need a little bit of help from yourself there.
Hi, David. Yeah, this happens automatically. The results should just come in, and then when we're confident that we've got enough votes, the results will appear on screen.
Okay. Fingers crossed. %70 have voted, so it's happening. I've actually found how to find it now. It's in the text box, so I'm a bit slow today. 75% voted. Okay, should we, still not sure how we see these results? Fingers crossed you can see them, I can't.
Yeah, they're there on screen. I can see them.
I don't know which screen you're looking at. Okay.
We've got a combination of 2 of the above winning with 63% of the vote.
Okay, thank you very much. That's great. Sorry, our last thing I need to do, and I'm very direct in my duty today, is to hand over to Sue Pritchard. I can see you, Sue. Away you go. Thank you very much.
Thank you, David. And I'm going to move into a slightly different mode here, and describe for you the vision for agroecology that we described in our report we published last year. The Food Farming Countryside Commission published last year, called Our Future in the Land. And we're describing a future scenario for agriculture, which we think answers many of the questions that are being posed across the whole of the EXPO. How we respond to the climate and nature challenge, but how we also provide a fair and just transition for farmers, farming communities, and for people's health and well-being. So the proposition that we make in Our Future in the Land is that the farming transition that we need is towards agroecology. And so this is my signal, just saying, this is my signal for the move. So we propose a transition to agroecology, which is based really on the United Nations Food and Agriculture Organization's definition, the FAO definition, which incorporates both physical and socio-economic elements, grounded, therefore, in the 3 pillars of sustainable development. So it's not just an environmental, a technical, or a technological solution to the farming challenges in front of us. It works across 10 interconnected and interdependent elements, offering a very practical, but also whole systems solution for farming. So essentially, agroecology is based on applying the ecological principles to optimize the relationship between plants, animals, humans, and the environment, as well as strengthening the social aspects of a fair and a sustainable farming system. So I'm going to scamper like mad through the 10 elements, and I think you'll see, therefore, why this offers what we think is the most plausible solution for farming in the UK and indeed around the world. So the 10 elements of agroecology First of all, based on diversity, that diverse systems are healthy and sustainable systems, and that means diversity not just in the kinds of farming practices that we deploy, but also in terms of farm businesses, farm sizes, about how we layer uses of land in any particular place. And that's, of course, deeply interconnected with the notion of building synergies between different practices. So when you ensure that practices are co-located or adjacent to each other, the synergies from one part of the system support and enhance the next. So agroecological practices are essentially more efficient, therefore. With diverse and synergistic practices, they become a more efficient use, a more multifunctional and efficient use of the resources that we have available. And critical to the, we'll move on again, one more. So critical to the components of agroecology is also about co-creation and sharing of knowledge. So building on the socio-economic aspects of agroecology is about building landscape resilience as well as farmer resilience, and strengthening the human and social values that are more likely to build more sustainable farming transitions. It also builds on cultural and food traditions. We don't talk about that in the UK very often, but evidence suggests in moving towards more sustainable food and farming systems, building on if you like, our indigenous culture, our indigenous food and farming practices is more likely to be more sustainable. So we grow more of the foods that we are climatically capable of growing, and strengthen the relationship between communities and their food and farming systems. And then moving on quickly, because I know we haven't really got much time. Embedded in agroecology is the notion of responsible governance and circular economies. So making sure that the way we organise for food and farming systems pay attention to the kinds of appropriate governance at different scales, so from national policy right through to local practices. And the image that I'm showing you here is from a Food for Life programme where local schools choose to buy high quality sustainably produced food and prepare it in schools for children. So it kind of closes the loop between what we grow on the fields and what we produce for people on their plates. So I'm going to whiz on now to ELMS, which stands for the Environmental Land Management Scheme, and it's the replacement policy from the old basic payment schemes, the Common Agricultural Policy basic payment schemes, to a new set of farm support that is based on environmental principles. Now, cutting straight to the chase, the reality is that the delivery of ELMS is currently in a somewhat stuck place. And whereas the aspiration for environmental land management schemes that farmers will be paid for developing and regenerating their land and their landscapes to support the development of public goods, the reality is that right now there's a great deal of anxiety about the way that scheme is actually going to manifest itself. So I'm going to assume that for most of you on this Zoom session, you'll have some familiarity with the broad brush of the ELMS schemes, but I'm just going to run through the critique that we've been making in the Food Farming and Countryside Commission and what we think is really, really important to strengthen in the current design, because it's still in a consultation process. So first of all, we think it is really, really important that any farm support scheme, any investment in shifting the whole farm system across the UK engages all farmers. At the moment, there's real risk that because the scheme as it's currently proposed is very unclear and farmers are getting increasingly anxious, that many farmers are likely to walk away from the promise of this scheme and just take their chances in a marketplace which at the moment privileges intensive agriculture over environmental systems. Now that would be a really, really backward step. So first of all, we think that the ELM scheme has to engage all farmers through accessible, university accessible entry-level payments which persuade farmers to participate in gathering and collecting and sharing high quality data across the key metrics that we've been talking about here: soil and water quality, biodiversity, wildlife, public access, carbon sequestration, among other things. The next thing that we think is really critical is that there has to be a timetable for introduction which makes sense to farmers. At the moment, farmers are really anxious about whether or not the departure from the old scheme and the introduction of the new scheme will enable them to maintain what would otherwise be viable businesses. So it's really, really important that those schemes target those behaviours and practices that do in fact create public value, things that we think are that both create public value in the traditional sense, but also those things that the public value themselves. So it's rapid investment in nature-based solutions, sustainable farming, and a different way of thinking about land use. So agroecological systems, in fact, work across all of these principles. And as we set out in our report, we think priorities should be about planting the right trees in the right places through high quality woodland creation and agroforestry, and in brackets, not a rush to the kind of 1970s style Sitka plantations that bring their own huge issues. We need to be investing in carbon protection and sequestration, in peat and in other sorts of soils, in creating and managing wetlands and waterways, in grassland restoration, in creating and restoring hedges, habitat corridors, functional habitat corridors, not the kind of simplistic or superficial habitat corridors. Managing public access, reconnecting people with nature and the countryside, nature improvement at scale, absolute, at landscape scale, but also alongside that, high animal welfare systems that build natural resistance to disease and minimize the use of on-farm antibiotics or other synthetic chemicals. So there needs to be a roadmap for the transition from where the farming system is right now. The last speaker, David, pointed to some of the real issues that that landscapes face through inappropriate farming practices, but farmers need a roadmap. Farmers need a roadmap and the right independent advice and farmer-led research, farmer-led innovation to help them move from where they are now to where they need to be. And at the moment, we're not completely confident that the ELM scheme, as it's currently described, does enough of that to give people the confidence that they need. So moving swiftly on, here's the question. How hopeful are you that the new ELM schemes will support the kind of food and farming systems that we need to respond to the climate and the nature and the public health emergencies, the triple challenges that we're facing right now? I'm having a little look to see how the voting is going. Numbers coming up, that's looking good. Good. It may well be that some of you are not familiar enough with the detail of the schemes, in which case I've got a question there, right there for you. Okay, so what does the answer look like? Oh, a little bit hopeful. Well, do you know, I feel the same way. A little bit hopeful, but what that means is all still to play for, and collective effort toward shaping the new ELM scheme through the perspective tests and trials and pilots and consultations that are all taking place right now is absolutely critical. Okay, so it falls to me now to introduce the next speaker, Paul Cottingham from the NFU. Paul.
Hi, so my name's Paul. I'm a little bit hopeful, it turns out. So I'm with a little bit of a grouping of people there. And thank you very much, Sue, and thank you to everyone else. And my first bit of full disclosure is I'm super proud of what our farmers have done, not only in the Southwest, but across the country in general around environment and food production. And also, second bit of, I expect that all of the solutions that have been presented so far will be a part of what we do. And I see multiple different ways of doing things as the way to go, because as there isn't one type of person, there isn't one type of farmer and one type of industry or anything like that. And just a little bit of a follow on from what Sue was saying, ELMS is crucial. And this isn't what I'm supposed to be talking about, but just some context for you. 16% of farmers in 2018-19 made a loss even with direct payments. Yeah, so the current support system. If they didn't have that, another 42% would have made a loss. The next system isn't going to have those kind of direct payments. So we are looking at quite a change of a system and an awful lot of farming businesses which are reliant on that kind of a support system. So anyway, on to nutrient management. So nutrient management and emissions trading, again, full disclosure, this is an awful lot of what I seem to be doing at the moment. And if we can move on to the next slide, please. It is kind of a little bit, if you're a bit old or into your kind of niche movies and stuff, you'll recognize this as Monty Python, the Holy Grail. It is a bit of a Holy Grail. Everywhere I go to at the moment, people are talking about how can you do trading? And it's one part of what perhaps we can be looking at. Next slide, please. So nutrient trading, and I've taken a quote here from Chesapeake Bay Foundation, where nutrient trading is around market-based programs that involve the exchange of pollution allocations between sources. Most programs involve exchanges between different point sources. Less common are programs that allow point source to non-point source trades. I think we're very used to having trading schemes where we've had like water companies trying to buy from farmers. And so farmers, again, very positively have been engaged with that. So in Wessex, they have been offsetting for the last 4 years or so about 40 tonnes across the Poole Harbour catchment. Okay, next slide. So my interest has been over the last 2.5 years putting together a voluntary farmer-led scheme for nutrient trading at scale, 800 odd kilometres of a catchment across Poole Harbour. And we've got some funding, which is what came earlier this year, was kind of slowed up a little bit with COVID, but we now have a project manager in place to take forward the next phase, which is about developing feasibility and the business plan and trying to get it all going over the next year. Next slide, please. And it will probably be easier if you just click through these things, yeah? So we got a farmer there. And the farmer is part of a farmer group. So we're setting up a legal entity. As part of that farmer group will be part of a partner group, a bit like Dieter Helm's operator system. And within that, targets are set in terms of what needs to be done. From there, those targets will apply to water companies and developers and farmers. For the Poole Harbour, the farmers have got to reduce by about 500 tonnes of nitrate across the year. Farmers will use a nutrient balancing tool or accounting tool, which will show what they're doing from all their operations. They can then use that to go into trading, and that will be, well, that goes into a trading bit and they can see whether they've got credits or debits. And then other buyers, so whether that's farmers, and then when farmers are set, you can also have water companies, and developers gets a little bit more tricky because if you're niche, you'll understand the Dutch end case. Anyway, so we can do some offsetting there. Next slide, please. So the reason why it's needed is Poole Harbour is an SPA, it's full of algae. Agriculture is a big source of all of this. And essentially, we're taking a voluntary-led approach because we would rather control what we're doing. Farmers want to control and own the situation rather than have a law brought in. Next slide. The opportunity is actually not only doing nitrates and becoming the most efficient nutrient farmers in the world, but actually to deliver other natural capital goods, because that's where it becomes interesting. Next slide. The threat, really, really easy to become complex and actually just to get a little bit too carried away with what you're doing. So we are exceptionally focused on delivering nitrate reductions for farming, and the other bits come after that. Next slide. The reason why there might be a difference now is essentially for all of the reasons probably everyone's come up, mentioned so far. We've got, a change because of Brexit. We've got a whole load of changes in our regulation and policy. We've got different buyers, all of those different reasons there. Okay, next slide. And what do we need to make it all work? I mean, I've generally expressed it as 3 things, but I've got a few more on there. I think in the end, you need rules, tools, and roles. So in order to have functioning kind of governance, you've got to understand how you will all work together. You need data that you can actually share between each other. You've got to know what you're all doing. So farmers will be obviously reducing their part, but folk like the Environment Agency, what do they do with areas like compliance? Next slide. And how can we get there? There are a number of reasons there. And the bit we're focused on, and it's hand in hand and not as opposed to what David was talking about, Southwest Water, which is an advisor-led approach. Our approach we're talking about is being a farmer-led approach, those that are actually the primary producers. And what we're looking at is aggregating all the sellers. And what we're kind of saying so far is that part hasn't been effectively done and is best done where it comes from that body, that community of people in and of themselves. And we take a pretty unpejorative way of doing things. We're just trying to create a system where everything can be done, and hopefully all the wetlands and good farming in the right places can happen where it will most efficiently and effectively be done. Next slide. Blooming heck, that was fast. There you go. I think I've kind of got to my time and we're into maybe doing a question. Right, folks, so we've got a multiple choice question and it is for you. Who is it most important to influence when it comes to getting change on the ground? And you've got a choice of 5. So you got your landowner, farmer, government, interest groups, the public, or all of the above, and hover over your buttons and off you go. Okay, this is much more interesting than I expected. We got 60% in. Your last few seconds, shouldn't be too tricky. Slowing down, that's nice. Come on, it's hardly hard. Okay, here comes your result. All of the above with a kind of second favouring of landowner farmer, and interest groups, interestingly, scoring 0. Okay, there you go. Anyway, thank you very much. Thank you for letting me present there. And I'm going to hand over to Rob Landell.
Yep, thanks, Paul. Thank you very much for that. I'm Rob Lamble from Natural England, and my brief today is to talk about the Catchment Sensitive Farming Project. What do we do? Is there any evidence it's working? And finally, what, if any, other plans for the future? Thank you. Well, firstly, the project started in 2006, and since then we've been offering specialist advice and training and grants to farmers, really encouraging voluntary action. And it's voluntary action that farmers can take to address diffuse pollution from farming. So 3 main partners to this are DEFRA, Natural England, and the Environment Agency. And it's really, thanks. DEFRA's 2-pronged approach to water quality, to meeting water quality standards, were the stick and the carrot. So the stick being regulation. So there's cross-compliance, nitrate vulnerable zones, and SAFO regs, and so on. And there's also the incentives and advice and catchment sensitive farming, along with others. We've heard about upstream thinking, and there's the voluntary approach for pesticides, but CSF comes under these incentives and advice. Now you might think, well, why are we giving grants and advice to farmers if they're polluting? But shouldn't the polluter pay? But it's very difficult to enforce regulation when we're dealing with diffuse water pollution. Thank you. I've mentioned the three main partners, but there's a lot more that have come on board since and that we've approached. Essentially, is anybody will work with anybody who influences farmers or who talks to farmers. Thank you. No, we've seen this headline already today from Ross, and you won't have failed to have seen it last month. This is the Guardian again headline saying that virtually all rivers are failing the good ecological standard. So 14% of water bodies, so a river is divided into water bodies for this purpose. And only 14% are reaching the standards we're looking for. Now, the problem's coming from all sorts of sectors, not just farming, but CSF is only talking about farming. But when you break down that figure, it's not to underplay that figure of such a bad state of rivers, but when you break it down, to reach a good ecological standard, they assess various parameters. And because it's one out, all out, if one parameter fails, then that water body fails. So if you break it down into actual individual parameters, then 77% pass. So as to say, that's not to undermine the scale of the problem, but it helps us prioritize where we put our effort. And so here's an example for Devon. CSF works across England. It's about 80 catchments involved, but we're just looking at the Devon ones here. And so essentially we're focusing in on areas where the main source of problems is coming from agriculture. And that's usually by default that there's nothing else in those areas, rural areas. And we're putting our effort into addressing those things that have failed. So starting at the eastern side of the map on the River Axe, the main issues there are phosphate and sediment. Coming across west a bit, we get to the Otter catchment, and there we can include fecal indicators. Coming further again west to the X, it's all those, plus some nitrate problems and in places pesticide problems. So we're trying to break down the problem and target the issues that are occurring in the water in the local areas. Talk about delivery. Well, the delivery really is could be the catchment officer. Each catchment has somebody like myself in post who goes out talking to farmers anywhere and any time we can. We also run farm walks and workshops on a variety of topics. There's some examples there. I don't know if you can read them, but essentially trying to improve farm efficiency in many ways. So the recommendations have an environmental improvement, potentially, and also a farm bottom line improvement. What we're saying often improves farm efficiency, reduces waste, and helps the farm as well as the local environment. We can also contract in specialist advice for these topics. And also CSF offers sort of access really to a lot of the countryside stewardship grants and some of the land-based options. The grant scheme's always been very popular, and it's certainly an important way to engage people. Farmers, if they can, they like to apply for them. There's a whole variety of grants. This is just a few. Roofing over a feed area by the look of it. If you can minimize the volume of dirty water you're generating on a farm, it reduces pressure on the store and reduces the pressure to spread it in appropriate times. It's not just roofing. Perhaps you don't need a roof. If you've had a specialist recommendation on infrastructure, they might say, well, you don't need a roof, or what you need is some clean drains going in here to separate the clean and dirty water. You don't need to go as far as putting a roof up, or there might be some concrete needed in a yard to help improve the separation of clean and dirty water. But before you do that, we might say, well, why don't you repair the gutters on that roof at the old traditional building? You might do the whole job properly, and again, it's available through the grant scheme. But I say it's not just about grants. Grants are important, but I think the advice is more important. And the two together are the best possible combination. So we can offer specialist advice really on just about any topic a farmer might need to know about. So there's examples here in nutrient management planning. This is crop nutrient planning, using the best of their manures and slurries, and then what they need to use from the chemical fertilizer. One here on slurry manure handling and storage options. Soil husbandry, looks like the field in the background there could benefit perhaps from a soil husbandry advice visit, and pesticides and so on. There's a whole raft of options available. And now coming on to, is CSF working? Well, this is the crux of the matter really, because there's a lot going on in the countryside. There's regulation, there's cross compliance, there's farm assurance schemes, all asking farmers to, improve their game in many ways. So we have to tease out, well, what change is arising as of catchment sensitive farming specifically. And so to reflect this, we use a variety of measures. We use I think it's Ipsos Mori, do a farm awareness and attitude poll of 2,000 farmers. They've phoned a telephone survey to see, are farmers aware of the issue of diffuse pollution? Are they aware they have a role in solving it? Do they know their name of their local catchment officer? It's a whole variety of questions. And then we of course know how many farmers we've engaged with, which is an interesting number, but it's engagement is only one thing. What's more interesting is how many measures have they taken up? How many of the recommended measures that we've suggested do they actually implement? And if they do implement them, is it because of catchment sensitive farming, or is it because of farm assurance or regulation, or they've always done it? It's nothing to do with CSF. It's teasing out those influences that have come about because of CSF. And we do this by following up a farm advice audit each year with a random number of farmers selected, and we go and interview them. And then finally, of course, there's actual real life, real world water quality monitoring that the Environment Agency do. So all those four measures really, modelling, measuring and surveying, contribute to the evaluation of CSF. And that's all summarised in the evaluation report, which if you're interested, you can find online. The CSF evidence team from the Environment Agency produces this report. And in a nutshell, it is working. It depends on what the pollutant is and where it is, but there's various percentages of improvement of the various pollutants that we're working with. Something like pesticide can be quite a significant improvement, 35% in some catchments, higher in others even. Sometimes phosphates and nitrates are lower, between 5 and 22% improvement due to CSF. But as we've said, there's still a lot to do. We're running to stand still in many ways with the increase in sort of extreme weather events. Even just standing still is quite an achievement some years. So we need to keep working at a landscape scale. We can tell from the appraisal that it's diffuse pollution, so we need to work at a landscape scale. We need to work with regulators. That was always the intention, that there was the pincer movement of regulation on one hand and advice and incentives on the other. And we need other sectors to do the part. The problem isn't all coming from agriculture. There's transport, the water companies, domestic, forestry. There's lots of other sectors involved. Thank you. Next slide. And we're currently involved in development work, ELMS, supply chain work. The farmers do listen to their milk buyers and to the supermarkets who, at the end of the day, pay them. They perhaps listen to them more than to others. So working with them has been a positive thing. Working with water companies and work on associated sort of benefits, really, that while we're on farm talking about water, well, we can also talk about natural flood management, and not just quality of water, quantity of water as well. And finally, the future plans, really. We've reached the end of phase 4 of CSF. We've been around since 2006, and we're looking at our next phase starting next year. Increasing geographical coverage, engaging more farmers. Say with diffuse pollution, you need to act far and wide to make an impact. Better integration of water and air priorities. We've only taken air on as a role in the last couple of years, so our target areas are very much water target areas. So air's been bolted on. It needs to be more ingrained. And looking at other opportunities while we're on farm giving advice. Well, there's other things that benefit, so we could dwell on those a bit more than we have done in the past, such as biodiversity and, of course, nature recovery networks. And all this is in a bid to DEFRA now for the spending review, so we should hope to hear soon. I think that's it from me. And now the multiple choice question. Should CSF expand to cover advice for farmers on additional topics, climate change and adaptation and mitigation, natural flood management, land biodiversity, or maybe all of the above? I'm here from Paul that 60% have voted here. I can't actually see the result, but it's steadily going up. We're up to 70%. Bit of a Eurovision moment waiting for the results here. I guess that might be it. That's here we are. Well, the results are, as you can see, all of the above. 68% voted for all the combination of all the additional roles, which in many ways we're already looking at, but don't count as a benefit in our appraisal.
Thank you. Thank you.
Okay,
Ross.
thanks, Ross. Thank you, Ross.
Thank you very much. Thanks to all the speakers. Thank you very much for all the participation. I hope you found it informative and fun. Could you please fill out the feedback form, which you can see on the chat? That's for Mindfully Wired, just to gather your feedback. But we're going to now launch you into a discussion group. You'll be plucked out of the air and put into a discussion room with a chair, and you'll be discussing 3 questions. And what I'd like you to do is basically just put your camera on. If you want to make a point, switch on your microphone and start speaking. We're going to break out for 15 minutes and then we're going to come back for a 5-minute plenary. Could I ask the chairs, please, to feedback on 2 main points from the discussion? Very quickly, we can share those and then we can let you go to lunch.